All right, so let's go ahead and get started. Welcome to Lab 3. One more left. One more left. All right, so Lab 3, here we're doing the statistical question where does the horsepower of a car serve as a reliable predictor for its fuel efficiency measured in miles per gallon, okay? What's interesting here is that, oh wow, this is interesting. Oh, the source, that's whatever. We're going to run this. Okay, boom. So run tidyverse that copilot package. I don't even think you really need this one, but whatever. For this, we're just gonna go ahead and just run this, and so we can view the actual data frame when it shows. Okay, so here's the data frame. Here's the variables, miles per gallon. We're gonna focus on horsepower and weight. Now let's go ahead and see this. Let's do this. Okay, so let's focus on which one is it? Fuel efficiency, horsepower. So that is HP. That's HP, okay? So what we're going to do here is say, just so that we can have some mental practice, the explanatory variable is going to be HP, and our response variable is going to be miles per gallon. And so this is not crazy, but the idea is for us to understand when to use simple linear regression. So this is simple linear regression because we're dealing with two quantitative variables. Okay, we want to see if one variable can predict another variable. Okay, and more so where both of them are quantitative. So here it says a variable a bunch of times. So logically, when it says x, you should be putting HP. Okay. Let's do that. So first, so where it says standard deviation, HP. And then this one, it doesn't matter. Okay, this is going to be HP for now. And then where it says a variable for y, we're going to put, what do you think? Miles per gallon, MPG. 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 And don't get rid of that comma. We need that comma. MPG. And then finally, MPG. So when I run this, I'm gonna get the summary statistics for the mean, and I'm gonna get the mean and the standard deviation for both variables, as well as the correlation between them. So to run this, I don't know why it should be slow, but you see that the mean, these are the means, these are the standard deviations. What I want to highlight is that our correlation is, you know what? Negative. With a negative correlation, that tells you something about our slope. If you remember the equation, the slope. Correlation has a direct impact on our slope. So let's see what it looks like. So our x variable again is horsepower, and then this is miles per gallon, MPG, and then here, okay, I would say this is going to be horsepower. Let's actually spell it out. Does anyone ever make your plot titles more, I guess, nice? Okay, so let's see what this looks like. So it should be should it be a positive slope or a negative slope? A negative slope. You know what? What's even more interesting is that yes, it's negative, but it seems as if there's more of a decreasing exponential curve. And so if you take more, stat classes, you get to see that a little bit deeper. So that's fun. So this is a visualization, and then last but not least, let's look at the analysis. So this is going to be where you have this order matters. Here, order definitely matters. So you need to make sure that this is MPG, and then this is going to be HP. This, you can erase this. I don't know why this did that. I can even just put one. Actually, just put one there, and then just put one right here again. Make this one, and then this will run the analysis. Boom. Come on, take your time, of course. All right, so here you get your y-intercept. Here you get your slope. By the time you're watching this video, you'll know this is standard error for the statistic. For the estimate, that still works anonymous in this case. The standard error is the standard error for this statistic, okay? This is the test statistic. This is the test statistic. This is the p-value. This is the p-value. This is the standard deviation of residuals. Maybe we've gotten that far. SE. And then this is R squared, okay? And that's it from the R output analysis-wise. So you should be able to answer the questions based on this output and what we've learned in class. But wait, you want another problem? Yes, of course you do. Let's do it again. All right, so can the weight of a car provide meaningful insights into the miles per gallon miles per gallon performance. So this is now going to be, I'm gonna delete that, put that down. We know our explanatory variable now is just going to be WT, the weight of a car, and our response variable is going to be miles per gallon. Okay, so here we do the same thing again. This is going to be WT, and this time I'm going to put WT here just so you can, I'm telling you, it's going to give you the same result. And this time I'll put miles per gallon here. Not this time, but this is where miles per gallon should be. Miles per gallon. Great, fantastic. Miles per gallon. Great, fantastic. Miles per gallon. Great, fantastic. All right, so then here when I run this, I'm gonna get my I'm gonna get my summary, not 5-number summary, but my summary. The Y should be the same from last example, and then you get your standard deviations, and then here's your correlation. Oh, this is negative. It's still negative. I shouldn't have. It's fine. It's fine. I'll keep it that way. So therefore, we know for a fact that this graph is going to have a negative association. It should be miles per gallon. This is going to be WT. Lost my train of thought. You make this look fancy with weight of a car. You see I can provide more detail if I wanted to. And then our plot, was it red last time? Let's make it like orange, Play with the plot so you can just, have fun with it, Don't make lab so draining. Have fun with life. Yeah, so this one's more linear compared to up here. This is more of an exponential decreasing function, whereas this one's a little bit more linear. Very interesting. All right, let's keep going. All right, so then all we got to do now is plug this to miles per gallon, make this 2, make this 2, make this WT. So annoying because it's being recorded. That's why. All right, here's a slope. Here's a y-intercept. What we discussed earlier, and then this is the r squared, and then this is the standard deviation of residuals. It's quite, what is it? 0.758, 0.752. Okay, that's good. Good to see. All right, thank you very much, and have a great rest of your day.